Find the inverse of the following 3 by 3 matrix. There are two basic approaches. One is very common, and it is to augment with the identity matrix and then do reduced row echelon form. The other is much less common and slightly more difficult, and it is the adjoint and determinant process. I believe that's the process that's used in the photo math, and so a lot of students are now starting to look at that and trying to prove that on tests. Rarely does someone get it right. There's just not a lot of evidence of it because it's not as easy. So I'm going to do the easy way, the way that's in the course and in the book and on most of the YouTube videos. And that is we augment the matrix 1, 2, negative 1, 0, 1, negative 1, negative 1, 0, negative 2. Let's make this a little smaller. With the identity matrix of the same size. 1, 0, 0, 0, 1, 0, 0, 0, 1. And now we proceed to do reduced row echelon form so that when we're done, the left side will look like the right side does at the beginning. Okay, starting off, we can do row 1 plus row 3. The notation, let's stick with the notation, new row 1 equals old row 1 plus old row 3, something like that. Okay, so row 1, 1, 2, negative 1, 1, 0, 0. Row 3, negative 1, 0, negative 2, 0, 0, 1. Adding up, we get 0, 2, negative 3, 1, 0, 1. Okay, and that's our new row 1. So let's write our matrix that has row 1 cleaned up. So we have, column 1. 1, 2, negative 1, 1, 0, 0, 0, 1, negative 1, 0, 1, 0. And we have a new row 1 called 0, 2, negative 3, 1, 0, 1. Okay. This next one, we're going to clean up row 2. Cannot get that. There we go. It's still not working. Come on. There we go. Nope. Are you serious? Alt-H. I can do it that way. There we go. We want to get this to be 0 and this to be 0. So how we can do this? The one that we're not trying to change is going to be the main one we use. So we can get a new row 1 by negative 2 row 2 plus row 1. Let's play that out. Negative 2 row 2 would be 0, negative 2, 2, 0, negative 2, 0. And row 1 would just be the 1, 2, negative 1, 1, 0, 0. Adding these up, 1, 0, 1, 1, negative 2, 0. And we can get a new row 3 by negative 2 row 2 plus row 3. That would be 0, negative 2, 2, 0, negative 2, 0. And row 3, 0, 2, negative 3, 1, 0, 1. Adding these up, we get 0, 0, negative 1, 1, negative 2, 1. All right, next matrix. This is the second column now cleaned up. So we have a new row 1, 1, 0, 1, 1, negative 2, 0. The same row 2, and a new row 3, 0, 0, negative 1, 1, negative 2, 1. There we go. Getting closer. Last thing we want to do is get these two to be zeros. The ones we're not changing, we're going to use. So we need a new row 1. And that's just going to be row 1 plus row 3. Or row 3 plus row 1. Either way, add these up. So that'll be 1, 0, 1, 1, negative 2, 0, row 1. And 0, 0, negative 1, 1, negative 2, 1, row 3. Add it up. 1, 0, 0, 2, negative 4, 1. And we can get a new row 2 by doing minus row 3 plus row 2. This would be 0, 0, 1, negative 1, 2, negative 1, and row 2, 0, 1, negative 1, 0, 1, 0. Add those up, and we have 0, 1, 0, negative 1, 3, negative 1. We are almost there. We have a new row 1. Let's write it. 1, 0, 0, 2, negative 4, 1. We have a new row 2. 0, 1, 0, negative 1, 3, negative 1. And our old row 3 is not quite the identity matrix, so I would also multiply this one by negative 1 and distribute before writing it down here, giving us 0, 0, positive 1, negative 1, positive 2, negative 1. And the inverse, A inverse, is the right side. It's 2, negative 4, 1, negative 1, 3, negative 1, negative 1, 2, negative 1. If you had time on the test, you'd want to multiply that by the initial matrix and make sure you get the identity matrix for the product. Okay, this is a long process, but it's really knowing what you're doing. It's no more than multiplying and adding, so the arithmetic is easier than the adjoint determinant process in most cases. All right, I hope this helps.